Once the components are soft mounted to the vehicle, you'll need to capture the images from the 4 cameras so you can perform a calibration. To capture the images from the cameras, you'll need to insert the SD card into the ECU if you haven't already done so. Once you power up the device, you should see the AVM's menu. Using the supplied InView 360 remote, navigate to the capture option and click OK to capture the images from the cameras. Once the images are captured, power down the unit and remove the SD card from the ECU. Transfer the card to your computer and open Windows Explorer. You should see 4 files labeled front, left, rear, and right.bin. Copy these files and place them in the output folder of your InView 360 software. Once you've transferred the bin files from the SD card to the output folder of the application, you can launch the calibration tool. To launch the calibration tool, double-click the calibration tool icon. The application should launch. In the first step, you need to select your vehicle type. In our example, we will select a fire truck. Once you've selected your vehicle type, you'll need to enter your vehicle pattern information. First, you'll enter your width and length of your vehicle. Once you've done that, you can click the computation buttons under View 1 and View 2 pixel pitch. We'll come back and explain what these values mean in just a bit. Next, you'll enter the pattern size, width, and height. These are the dimensions of the calibration pads used. Below that, you'll enter the horizontal and vertical spacing measurements that you used during the measurement stage. Once you've entered all your data for your vehicle pattern information, you can click Confirm. You'll see that an image appears here. This image represents the amount of area you'll see when looking at this vehicle from a bird's eye view. In essence, this is your 360 image. As I mentioned earlier, we would come back to look at pixel pitch and explain what that means. You can imagine pixel pitch as the amount of zoom that you have on a vehicle when looking at it from a bird's eye view. If you increase your pixel pitch to the maximum value, you are in essence zooming out on that vehicle. The trade-off is you will see less detail in the surrounding area. If you decrease the pixel pitch value or zoom in, then you'll see less of the surrounding area, but you can make out much more detail. This is useful if you want to see things like vehicles or pedestrians or parking lines. So which pixel pitch value is correct? Well, that really depends on your needs. There is no correct answer, but as a general rule, you can use the default pixel pitch value that the system computes. You'll notice here that there is a View 1 pixel pitch and also a View 2 pixel pitch. If you look at the image here, this is the View 1 pixel pitch. If I use the View Mode selector to switch the image to View 2, you'll notice that the image changes from a portrait mode to a landscape mode. So which one do you use? Well, that depends on how you want to mount the in-cab monitor in the vehicle. If you are using your in-cab monitor in a landscape mode, then you will want to calibrate the cameras using a View 1 format. If you are using your monitor in a portrait mode, then you will want to calibrate the cameras using a View 2 format. Just a quick note, depending on the version of calibration software that you're using, you might see View 1 and View 2 displayed as NT mode for View 1 and ST-FT mode for View 2. NT mode stands for normal top mode, and ST-FT stands for separate top full top mode. Here's a more in-depth explanation on these different view modes and how they appear on the monitor in the vehicle. Let's take a look at view mode 1 or NT mode first. As I mentioned earlier, view mode 1 is used when you want to mount your monitor in a landscape format. Here's how the view mode 1 image would appear on the monitor in the vehicle. When you choose to calibrate in view mode 1, you will get the 360 image on the left of the monitor. You'll get the single camera image on the right. And using the driver button, you can cycle the image on the right to display the top and front, top and right, top and left, and top and rear camera images. Using View 2 or STFT mode will give you the 360 image on top and the single camera image on the bottom of the monitor. And using the driver button, you can cycle so that you get the top plus the front, top and right, top and left, and top and rear. If you are using View Mode 2, however, you get the option that you wouldn't get in View Mode 1, which is the full top mode. With this mode, you can see the entire 360 image in the monitor. In our example, we will stick with View 1 because we want to mount our monitor in a landscape mode. Once you've selected your view mode, switch to the next tab for your top view calibration.